right, this is your review for Unit 6, the trig unit, activities 31 through 33. So we're going to go through and hopefully cover all of the major topics here that will be included for your embedded assessment as well as for your activities 31 through 33 quiz. The first several problems, numbers 2 through 4, oops, I wrote 2 through 3, so let's say 2, 3, 4, 7, and 8 are all the same type. All of these problems are asking you to find an arc length. Remember that it's not always going to directly say find the arc length. Sometimes it just says to find the distance. So it's really important that you know that anytime we're trying to find distance on the edge of the circle, that by definition that is an arc length. So all of those problems, we are finding an arc length. And in class, we learned 2 different ways that you can find the arc length. So I'm going to go over both of them for how you can do that, so that way you can kind of choose the method that you prefer. So we're going to start with number 4 here, and number 4, it is asking you to find that arc length, and in 4A, it gives you that the information that is given to you is that the radius is 11, and it also is giving you that the angle of rotation is 120 degrees. So you should know, because it's on the chart that you have to memorize, that 60 degrees is pi over 3 in radians, which means that 120 degrees has to be double that. So 120 degrees then, we should pretty easily be able to figure out, if you don't have it memorized, is 2 pi over 3. So that is the angle of rotation in radians. One of the ways that we found arc length in class was using the formula arc length equals radius times theta. But remember, and we wrote this in like capital letters or underlined it or did something to indicate that theta has to be in radians. You cannot use this formula if your angle is still in degrees. So once we've found or know that 120 degrees is 2 pi over 3 radians, then it's just a matter of plugging into this formula. So arc length equals radius, which is 11, times theta, which in radians is 2 pi over 3. So remember that since this 11 does not have a denominator, that its denominator is 1, and when we multiply fractions, we do numerator times numerator, denominator times denominator. So 11 times 2 pi is 22 pi. 1 times 3 is 3. So we get 22 pi over 3 in radians. I believe that the directions on this one said find the approximate distance. So when it tells you approximate distance, that means you're going to go ahead and press this into your calculator. So press in 22, then hit your pi button, hit enter, and then press divided by 3 and enter again. And that will give us our approximate arc length. It doesn't say what to round to, but even if we go to the nearest tenth here, it actually rounds to 23.0. And anytime you are asked to find a distance, do not forget your label. Really, really important that you remember those labels. So that's 4A. Again, all of these problems, 2, 3, all of 4, number 7, number 8, they're all asking you to find arc length. And you can use this formula for all of those. But I just want to kind of illustrate how we can use the other formula as well. And I'm going to use that one on number 7. So number 7 was one where they gave you a picture. So you had 25 centimeters marked as your radius, and then the angle that you were given, sorry, that's a bad looking sector, but we'll pretend, it's labeled 112 degrees. So certainly, again, if you prefer always using this formula, you are allowed to do that. You would simply have to convert 112 degrees into radians and then plug it into the formula. But I do want to remind you of the other way that you can find arc length, and that is by taking the portion of the circle that you have. So in this case, it's 112 degrees is what we have. The whole circle is 360 degrees. And we can multiply that ratio, because that's how much of a full circle that this arc length would cover, and multiplying that by the circumference. So in this case, remember that circumference equals 2 times pi times radius. So 2 times pi times 25, which in this case would give us 50 pi. So this is the other way that you can calculate these. This one, I can't remember whether it said to find approximate or whether it asked for exact. So I'm just going to do both in this case. So that way we are covered. So for the exact, whenever it says exact, that means we're leaving it in terms of pi. So when we do that, it's your choice whether you want to multiply first and then reduce, or whether you want to reduce first and then multiply. I always reduce first, again, because that usually allows me to do it without my calculator, but that's totally up to you. So I would reduce the 112 over 360. They're both divisible by 8. So when I take 112 and divide it by 8, I get 14. When I take 360 and divide it by 8, I get 45. So this is 14 over 45. And then I would also, now that I've reduced up and down, I'm going to reduce across, because 50 and 45 are both divisible by 5. So 45 divided by 5 is 9. 50 divided by 5 is 10. So then when I go across there, 10 times pi times 14 is 140 pi. And on the bottom, 1 times 9 is 9. 140 and 9 do not have any common factors, so that's as far as we can go. Again, if we are remembering our label, this would be your exact answer, 140 pi over 9. And then if it wanted the approximate answer, then you would press in 140 pi and then divide that result by 9, and that would be about 48.9 centimeters. Again, regardless of which way it wants your answer, make sure that you don't forget the label. The label is very, very important. So again, 2 ways that you can do these. You can either use S equals R times theta when theta is in radians, or you can take circumference times the fraction of rotation. So both of those are useful for all of these problems that are up here. So then the next several problems that were in your review were asking you to convert from degrees to radians or radians to degrees. So again, all of those are done exactly the same way. So I'm just going to do one of each. So for degrees to radians, I'm going to do number 10A. So 10A, your problem was 48 degrees. Again, we're converting from degrees to radians. When you are converting from degrees into radians, our process is to multiply by pi over 180 every time. So I take 48 and I multiply it by pi over 180. Again, since 48 doesn't have a denominator, that means its denominator is 1. So here, certainly you can multiply first and then reduce, or reduce first and then multiply. Does not matter. So if I multiply first, I end up with 48 pi over 180, and then I need to reduce these. The biggest number that both of those are divisible by is 12. So if I divide 180 by 12, that gives me 15. If I divide 48 by 12, that gives me 4. So that gives me 4 pi over 15 is the radian equivalent for 48 degrees. So When we go from degrees to radians, this is always our process. When we go the opposite way from radians into degrees, then we do the reciprocal, and I'm going to do, let's see, number 11E, which was 11 pi over 9, because I'm trying to choose one that's not on the unit circle here. So whenever we go from radians to degrees, it's the reciprocal of what we do for degrees to radians. So we multiply by 180 over pi instead in this case. So I take my 11 pi over 9 and I multiply it by 180 over pi. So the pi's are going to cancel each other out across here. I would also reduce these because 9 and 180 are both divisible by 9. In this case, 9 divided by 9 is 1. 180 divided by 9 gives me 20. So then on the top, my pi's canceled, so all I've got is 11 times 20, which gives me 220. On the bottom, I just have 1 times 1. So 220 degrees is my answer there. Again, please use common sense. If you are converting into degrees, there should be no pi's in your answer. If you're converting to radians, there should always be a pi in your answer. So just make sure that you check that, with your common sense meter once you have finished the problem. All right, next one that I'm going to do is number 17. Number 17 and number 18 are done using the same idea, and really what it's asking you to find in these is an arc length, but I wanted to explain this one because, again, we did ones like this in class, but this is not as straightforward as the one that we went over in number 4 and earlier in the recording. So on number 17, it's because they're giving you a rotation in terms of time instead of giving it to you in degrees. So we're still finding arc length in 17 and 18, but we're using time here. So it says that one rotation here happens every 80 seconds. So certainly you can still use either the arc length formula or the circumference times portion of rotation formula. It does not matter. In 17, it tells you that the radius is 15 and it wants to know how far it goes after 60 seconds. Now, again, you can go either way here. If you know that an entire rotation around the circle is represented by 80 seconds, and you want to figure out how much then 60 seconds would be, you could do that. So if you think that way, that's great. And you could say, okay, if 80 seconds is a full rotation, that means every 90 degrees is represented by 20 seconds. So if you do it that way, then you can see that 60 seconds, and I'll change my color here, 60 seconds would bring you here in the coordinate plane or in rotation, and in radians, that is 3 pi over 2. So if you are doing this using S equals R times theta, then your theta is going to be 3 pi over 2. Obviously, your radius is 15. So arc length equals 15 times 3 pi over 2. The 15's over 1. Here there's nothing that reduces, so that gives us 45 pi over 2, which then, again, we can approximate using our calculator, and that gives us about 70.7 feet. So that's one way to do this problem. The other way to do this problem is, again, to do circumference times the ratio. So if I do it that way, circumference equals 2 times pi times 15. So circumference is 30 pi. So arc length would equal 30 pi times the ratio. Well, the full rotation is 80 seconds. Here I'm going 60 seconds. And then this is how you could also calculate it. Obviously, the zeros cancel. Both 6 and 8 are divisible by 2, so that gives you 3/4. This is over 1. So then you could reduce the 4 and the 30. They're both divisible by 2, so 2 and 15. And then note that we get the exact same thing. We get 45 pi on the top. We get 2 on the bottom. So again, it does not matter which way you choose to do this. So number 18 is the exact same thing, except that instead of 60 seconds, it's 140 seconds. So you can either do 140 over 80 and use the new radius that they give you and do it this way, or you can figure out the radian equivalent of 140 seconds when a full rotation is 80. So again, that's totally up to you which way you do it. You should get the same answer either way. So that covers all of activity 31. Moving on to activity 32, where we found several things. So first thing we did was sketch angles in the coordinate plane. So I'm going to do 2 of these, one in degrees and one in radians. So I'm going to do number 1b for degrees, which was 575 degrees. So the first thing you do, remember, when you're sketching an angle in standard position is draw yourself a coordinate plane, because standard position angles always need to be in the coordinate plane. So 575 degrees is a positive angle, which means I always start over here on the positive x-axis, but positives mean I'm going to rotate in a counterclockwise position. So when I make one full rotation, that's 360 degrees. Now, 575 degrees is 215 degrees more than 360. So I know I need to go another 180, again, because I'm trying to get to 215. So if I go 180 more to get to 215, I only need to go 35 more degrees. Now you know that halfway into this quadrant is 45 degrees, so you just need to go a little bit less than halfway. And then you draw your terminal side of the angle and you label it 575 degrees. All right, so that's a positive angle. This one happens to be in degrees. Then the second one I'm going to show you is in radians, and it's a negative angle, so that way we've kind of covered all of the possibilities here. So my angle is negative 9 pi over 4. Because it's negative, that means I'm going to travel in a clockwise direction, so we always start at the same place, right here on the positive x-axis. Remember that I should look at this and think of it in terms of fractions. 9 over 4 is 2 and 1/4. So this is the same as negative 2 and 1/4 pi. And we have to be able to think in terms of radians. Remember that one full rotation is 2 pi. So when I have rotated in the negative direction, one full rotation, I've used up 2 of my 2 1/4. So I only need to go 1/4 pi more. And you should know from your memorization chart that 45 degrees is pi over 4. So we're going exactly halfway into this next quadrant. And then again, once you draw your terminal side, you also need to make sure that you label the angle that you drew. So negative 9 pi over 4. All right, next thing that we went to were coterminal angles. It asked you on these to find one positive and one negative coterminal angle. So I'm going to look at 5A and 5D. So 5A, it starts with negative 65 degrees. And again, you're supposed to find one positive and one negative coterminal angle. Remember that in degrees, we find coterminal angles by adding and subtracting multiples of 360 degrees. So here, if I take negative 65 and I add 360, I get 295 degrees. So this 295 is a positive coterminal angle. Now again, you could keep adding 360 if you want. 295 plus 360 is also a valid answer. I just usually list the first ones. So I also need, according to the directions, a negative coterminal angle. So I'm going to take negative 65 and I'm going to subtract 360 degrees. And that gives me negative 425 degrees. So there we go for our answers for 5A. For 5D, this one, 8 pi over 3. So this one's in radians, which means our answers need to be in radians. So instead of adding, subtracting 360, we're going to add and or subtract 2 pi. So this original angle is bigger than 2 pi because 3 goes into 8 more than, 2 times. It's 2 2/3. So I am going to start here by taking 8 pi over 3 and subtracting 2 pi. Remember that when you subtract, you need a common denominator. So I'm going to change this 2 pi to 6 pi over 3 because, again, this one had a denominator of 1. So if I need to multiply the bottom by 3, I also multiply the top by 3. So instead of writing 2 pi, I'm going to write 6 pi over 3. So now 8 pi over 3, take away 6 pi over 3, is going to give you 2 pi over 3. So 2 pi over 3 is a positive coterminal angle for 8 pi over 3. Now notice that I subtracted and the answer was still positive. So that means if I want to find a negative, I'm not just subtracting from this guy, I'm subtracting again from this guy because I have to get it so that it's negative. So now I'm going to take 2 pi over 3 and I'm going to subtract 2 pi, which again is 6 pi over 3. 2 minus 6 is negative 4 pi on the top. And of course, denominator stays the same, which is 3. So a positive coterminal angle is 2 pi over 3. A negative is negative 4 pi over 3. Now, if you automatically started by adding 2 pi over 3, and so, you did this, and you got 14 pi over 3, that's okay. That's also a correct answer. I just usually list, the ones that are closest to 0. But if you listed for your positive 14 pi over 3 and your negative 4 pi over 3, that's perfectly okay. Those are valid answers. After coterminal angles, then we were asked to find reference angles. So, again, I'm going to do one of those, one of each type here. So first I'm going to do number 8B, where theta is 530 degrees. So you don't have to sketch the angle, that is optional, but it helps me to visualize where I am in order to sketch that. So 530 degrees if I'm rotating. Again, I'm rotating in a positive direction here. So 530 is bigger than 360, and you're going to have to know how much bigger it is. So when I sketch this 530 degrees, I'm going to start at the same place as when I would just sketch them, and that is on the positive x-axis. So first thing that I have is starting here, 530 is a full rotation plus an additional 170 degrees. So 170 is so close to 180. So if I were sketching it, it would go right here. Remember that the reference angle is the angle formed by the terminal side and the x-axis. So this right here is my reference angle. It was almost to 180, but it was 170 over, which means that this reference angle is 10 degrees. So that is our answer for 8B is 10 degrees. Then I'm going to do one in radians as well. We'll do C since it's negative, negative 12 pi over 5. So again, the sketching is optional. If you can come up with the answer without a sketch, that's fine. I just like to illustrate it for people. So 5 goes into 12 2 times with 2 left over. So this is 2 2/5 negative pi. So I'm going to rotate in a clockwise direction. I go around once. That gives me 2 pi. Now I need to go 2/5. 2/5 as a fraction is just slightly more or slightly less, sorry, than half. So I need to go slightly less than half a pi, which would be right here, right? Because I know that every 90 degrees is half a pi. So reference angles again are formed by the x-axis and the terminal side. So my reference angle is what's in red right here. So it's how much over the 2 pi I went, which what I went over the 2 pi was 2/5. So my reference angle is 2 pi over 5. Remember that reference angles are always acute angles. They're always positive. Okay, last things that we did in lesson or activities, I should say, not lesson, activities 32 were finding the sine, cosine, and tangent of various angles. So again, that depends on you being able to find reference angles for most of them. I'm going to do one that is quadrantal, and then I'm going to do one that is not, where it has one of our standard reference angles. So the first one I'm going to do is number 10B. 10B, it tells you that theta is 450 degrees, and it wants you to find the sine and cosine. So again, we can't find the sine and cosine if we don't know where 450 degrees is. So 450 degrees is 90 degrees more than 360. So if I'm sketching it, I go to 360 and then I go 90 more. So it's right here. It's a quadrantal. It is coterminal with 90 degrees, which means that its sine and cosine are the same as that of 90 degrees. So on our unit circle, that point has the coordinates 0, 1. And again, because the coordinate xy is cosine, comma, sine, that means that the sine of 450 degrees is the same as the sine of 90s, which is 1. And the cosine of 450 degrees is the same as that of 90s, which is the x-coordinate, which is 0. So sine is 1, cosine is 0. The other one I'm going to do is number 21, where it asks you to find the sine, cosine, and tangent of 13 pi over 3. So again, first step is knowing where 13 pi over 3 is, because we have to know what its reference angle is. So 13 pi over 3, 3 goes into 13 4 times with 1 left over. So that's 4 1/3 pi. So 2 pi is 1 rotation. So 4 pi is another full rotation, and then the 1/3 means I end up here at a 60 degrees or pi over 3. So my reference angle here is pi over 3 or 60 degrees. I am in quadrant 1, so I am going to use the sine and cosine values of quadrant 1. So in quadrant 1, 60 degrees, its coordinates on your unit circle that you look at for 60 degrees, its cosine is 1/2 and its sine is radical 3 over 2. So when I'm listing my sine of 13 pi over 3, It's the same as the sine of 60 degrees. So sine is the y coordinate, so it's radical 3 over 2. The cosine of 13 pi over 3, again, is going to be the same as 60 degrees, which is 1/2. Remember that tangent, you always have to do some work on. Tangent, we find by taking sine and dividing it by cosine. So the sine value is radical 3 over 2. I want to divide that by 1/2. Remember that when we divide fractions, it's multiplication by the reciprocal. So when I do that, these guys can cross cancel. So on the top, I have radical 3 times a 1, which is radical 3. On the bottom, 1 times 1 is 1. So radical 3 over 1, which is just radical 3. So the tangent of 13 pi over 3 is just radical 3. All right, so that wraps up activity 32. Only one left is activity 33. So on this one, first couple are just asking you where things are positive and negative and whatnot. So the next one that I want to do is to look at number 8, where you're using your Pythagorean identity. So it tells you that the cosine of theta is negative 3 radical 2 over 6, and that theta is between pi and 3 pi over 2. So remember, this tells you what quadrant we're in. This is quadrant 3, between pi and 3 pi over 2. So it's right here, because here's pi and here's 3 pi over 2. So we're in quad 3. This is my cosine value. Remember that I told you in class, always reduce these first. So if I do that, these are both divisible by 3. So that gives me negative radical 2 over 2 as the simplified cosine value. So that is what I'm going to plug into the Pythagorean identity. Again, this does you no good if you don't know the Pythagorean identity. It's sine squared theta plus cosine squared theta equals 1. So now I'm going to plug this guy in for my cosine of theta. So sine squared theta plus negative radical 2 over 2 squared, because that is cosine squared theta, equals 1. So now I need to perform the operation here. So when I square this, again, that's like multiplying it times itself. So negative times a negative gives you a positive, so you know the answer is positive. Radical 2 times radical 2 is 2. 2 times 2 is 4. And 2 over 4 reduces to 1/2. So this is sine squared theta plus 1/2 equals 1. Now to solve, I need to subtract 1/2 on both sides. So sine squared theta equals 1/2. Now to solve for sine of theta, because that's what the directions asked for, were sine of theta and cosine, or sine of theta and tangent of theta. So now I need to take the square root. So square root of sine squared theta is just sine of theta. When you take the square root of a fraction, it's square root of the top over square root of the bottom. So square root of 1 is 1. The square root of 2 does not simplify. It's just radical 2. Can't leave your answer like this. We have to rationalize the denominator. So multiply top and bottom by radical 2. So that gives me radical 2 over 2 for my sine. Remember that you have to check to see whether it should be positive or negative, because technically when we solve by square roots, we get both. But because we know we're in quadrant 3, only one of the answers is right. And in quadrant 3, if we look at all scholars take calculus, tangent is positive, which means that my sine value should be negative. So the sine of theta is negative radical 2 over 2. So only thing left to find is my tangent of theta here. Remember that tangent of theta is found by taking the sine value and dividing it by the cosine. In this case, the sine and the cosine are the same. So anytime you divide two things that are the same, the answer is 1. So you don't have to take the time to multiply by the reciprocal. You should know that you're going to get 1. Again, you double check. In this quadrant, tangent should be positive, so make sure it's a positive 1 that you are listing. All right, last thing here are the reciprocals, the reciprocal identities. So I'm going to look at number 12 and then number 17, and then we're done. Number 12 asks you to write 1 over cotangent of theta in 2 other ways. So if you know your reciprocal identities, then you know that cotangent and tangent are reciprocals. So here, if you have 1 over cotangent, that means that that is the same as the tangent. So tangent of theta is one of your answers. The other answer is the fact that we know that the tangent of theta, because it's y over x, is going to be sine theta divided by cosine theta. Again, it's this fact that we used to solve to find tangent here and in our other problems. So tangent of theta and sine of theta over cosine theta are the 2 other ways to write 1 over cotangent. Last one is 17, where it tells you to take sine squared theta plus cosine squared theta equals 1, and to multiply it by the cosecant squared theta. So first thing I need to do is actually perform that multiplication. So multiply all 3 terms by cosecant squared theta. So that gives me something that looks like this. And then I'm going to make some substitutions. I know that cosecant is the reciprocal of sine. So that means that cosecant squared is 1 over sine squared theta. So this plain sine squared theta doesn't have a denominator, which means its denominator is 1. Here, again, cosecant squared theta, I'm substituting sine squared theta. Cosine squared theta doesn't have a denominator, so it's going over 1. And cosecant squared theta, again, I substitute here. Remember that in this substitution step, we try to put everything in terms of sine and cosine. So next, I'm actually going to multiply. So that over here gives me sine squared theta over sine squared theta. Here, that gives me cosine squared theta over sine squared theta. And then here I still have 1 over sine squared theta. So now we try to reduce because we are not allowed to leave fractions in our final answer. Sine squared theta over sine squared theta is just 1. Cosine over sine is cotangent. So because these are squared, that's going to be cotangent squared theta. Over here, there's nothing else that I can do. So I actually can't leave it like this because that is a fraction. So I go back to when I had just written it as cosecant squared theta. So cosecant squared theta is going to be my right side, and so that is my final answer. All right, so that covers activities 31 through 33. Happy studying!